Tonight's lesson is on graphing absolute value. And in order to graph absolute value, we first have to think about what absolute value means. And this is actually good review for your midterm. The first thing I'd like you to do is try and solve each 4 of those problems. Okay? Remember, you need to set up 2 cases. So if you forgot, you can stick with me. I'm hoping that most of you will remember, and you can pause here and come back and check your exceptionally correct answers. Okay, so the first thing I would do is I would say 3x plus 5 equals 7, and 3x plus 5 equals negative 7, and then I would solve them. So I get 3x equals 2, and 3x equals negative 12, and x equals 2/3, and x equals negative 4. Now, the other thing you need to remember about absolute value is always to go back and check. And if you do go back and check, these will both work, because I would get 2 plus 5 is 7, and I would get negative 12 plus 5, negative 7. Absolute value of negative 7 is 7. All right, so if that's a good reminder, at this point you should pause and go ahead and do them on your own. All right, so we need to isolate the absolute value first. So I would get 2x minus 7 equals 9, and then I'm going to set up 2 cases. So 2x minus 7 equals 9, and 2x minus 7 equals negative 9. And in this case, I'm going to get 2x equals 16, x equals 8. And I'm going to get 2x equals negative 2 and x equals negative 1. And I should at least do a mental check of those, and they are both fine as well. Back in the original, by the way, not in your modified version. Okay, the next one, I should get x equals 1/3. And I'm not going to go through all that. I'll let you do it on your own. And x equals 1. And then this one, lovely fractions. You should persevere through this. As I saw with a couple examples in the last unit, you know, you guys tend to get scared away from fractions. So try this on your own, and x should be negative 23/4, or x is 71/4. Okay? All right, so graphing absolute value, we have to usually use a table, and we're going to check our domain. Where is y equal to 0? Because you can't have a negative value for absolute value, right? I mean, it's never going to be negative. So that gives you the turning point of your graph, wherever y equals 0. After you find the turning point, you can choose some values on either side of that x value to get what the graph looks like. Now, number 1 is kind of the one that's a little different from all the other absolute value graphs. And if you notice that, that line would also be different. X equals 3, what would that look like? That's the line 1, 2, 3, x equals 3 right here, okay? But x could also be negative 3. That's kind of, well, not exactly symmetrical, and it should be, but that's the graph of the absolute value of x equals 3. Okay? That one's going to look a little different from the others. If you think about this graph, where is y equal to 0? Well, y is equal to 0 when x is equal to 0, right there at the origin. Then if x equals 1 or negative 1, y would be 1. If x equals 2 or negative 2, y would be 2, etc. So it's going to look like this, and I made mine a little steep. Hopefully yours is better. This line should actually, I don't know if it'll let me turn it, but it should be, oopsie, didn't take that down. It should be turned a little, okay? So hopefully yours is a little more symmetrical there. And that's the graph of y equals the absolute value of x. Now, where is y equal to 0 in this case? Y is equal to 0 when x equals 2. So that's going to be the turning point on my graph here, okay? So if I think about a table, x and y, when x is 2, y is 0. When x is negative 1 or negative 1, this is going to be 3. And if x is 1, then y is going to be 1, okay? So is that right? 1 minus 2, negative 1, yeah. Okay, so you have to kind of work this out here. If I had 2, 0, then I would have -2, 4, and I would have 0, 2. Okay, so I'm just kind of going through some different values here. All right, so that's going to look like this, ching, ching, basically. All right, y equals the absolute value of x minus 2. In number 4, if you take a look at this, what would the turning point be? You'd have to find out where y equals 0. So what value of x is going to give you a y value of 0? And you could just set that equal to 0, and you would get that x would be 4. Okay, so I know that 4 is going to be my turning point here. 1, 2, 3, 4. That's going to be the turning point of my graph. And then I can pick values on either side. So I would definitely want to pick multiples of, you got it, multiples of 2, even numbers. Okay, so I can also pick 0. But let's take 2 here. If x is 2, y is going to be 1. If x is 0, y is going to be 2. If x is 6, y is going to be 1. Okay? So that's going to be 0, and it's going to kind of come, let's see, 4, 5, 6 is also going to be 1. So it's going to kind of come like this, right? And that's the graph of y equals absolute value of 1/2 x minus 2. Now, from what you know about lines and thinking about this particular equation, I would like you to think about why the graph behaves the way it does, okay? And think about if this were the line here, what would the equation of this line be? Okay, and what would the equation of this line be? Okay, and then see if you can compare that with the equation that we're given here involving absolute value. I want you to think about that tonight, okay? And in addition, then we have this absolute value equations sheet that I would like you to do all of the odds on. Okay, so complete all of the odds, please, for tomorrow, and we'll continue with absolute value then. Have a great night.